Good day, students. We thank God for making it possible for us to be here this morning. The Bible says we should not depend on all our understanding, but everything we should recognize Him as a source, and He will direct our path. So I believe in prayer. Let's start with the word of prayer first. Lord, our Master Jesus, we thank you, bless your name for today, for making it possible for us to be here. We can't start the class without you. That's why I commit everything into your hands. Lord, give us the ability to reason, ability to understand. Where we find difficult to understand, Holy Spirit, help us. Now the end, give the glory back to you. We thank God. In Jesus' name, pray thanksgiving. Amen. God. Today, we are going to study a very important subject called sequence and series. This subject is very important. It plays a very important role in our various lives, various aspects of lives, in our family life, in governance, in business. This subject is very important. So please pay attention so you understand the basis. Good. So here, when we talk about sequence and series, it helps us to do some projections. For example, if the government wants to know maybe every year the population of Ghana increases by 3 million, we can project and know that by 20 years to come, what will be the population of Ghana? Sequence and series will help you to determine that one. Or you are in a business. Now, the item that you are using for production, every year it increases by maybe 2 million. You can project and know that by this number of years, that will be the amount that I need to in order to stay in business. So sequence and series is very, very important subject. So please pay attention, God. So first, by the end of this subject, God, you try to define a sequence and series. You try to define some of the terms or the types of sequence and series for today. So that's the main objective for today. Define sequence and series. First, you define some of the terms. And the third one is for the types of sequence and series. Go. So we start with the first one. So let's define sequence and series. Definition. Definition. Go. Now, a sequence is a set of numbers that follows a pattern or a rule. A sequence is a set of numbers that follows a pattern or a rule. So any set of numbers that follows a pattern or a rule is called sequence. For example, when you take examples. When we take 3, 5, 7, 9, ... This one is a sequence because it follows a pattern, and the pattern is +2, +2, +2. So this set of numbers is called what? Sequence. Let's take another one. Now when you take 3, 9, 27, 81, 243, this one is also a sequence because this one also follows a pattern, and the pattern is times 3 times 3 times 3 times 3 times 3. So this one is also a sequence. Go. So in short, any set of numbers that follows a pattern or rule is called sequence. Go. But when we take a numbers like 3, 4, 7, 9, 10, this set of numbers does not follow any pattern. So this one is not a sequence. Go. So now we know the definition of a sequence. A set of numbers that follows what? A pattern. Go. Now, in any sequence, if you know the pattern or the rule, you can predict the next number. In any sequence, if you know the pattern or rule, you can predict the next number. Go. Now, let's take a sequence like 4, 7, then 10, 13. Go. Now, let's look for the pattern first. For this sequence, the pattern is +3, +3, +3. So that's the rule or pattern. So we can predict the next number. So if the pattern is +3, +3, +3, then the next number +3, 13 +3 will give us what? 16. Now here we are able to predict the next number because we know what the pattern. So for a sequence, if you know the pattern, you can predict the next number. Go. Now, a number in a sequence is called 10. A number in a sequence is called 10. Go. Now, when we take the first example, here we have 4 terms here. That's 3, 5, 7, 9. Each number is called 10. Now, for the second one, we have 1, 2, 3, 4, 5. We have 5 terms. A number in the sequence is called what? 10. Go. So for the example, this example, The third term is 1, 2, 3. The third term is what? 27. Go. Because 27. Go. So that's the term. A number in the sequence is called term. Go. Now, when the terms of a sequence are linked together algebraically, then we have what is called series. When a terms in the sequence are linked together algebraically, then we have what is called what? Series. Go. So the difference between series and sequence is that for series we use additional sign or subtraction sign to link them. So when you link them together, that will give you what? Series. Go. Now let's take examples of series. Examples of series. Take examples of series. Examples. A. 3 plus 5 plus 7 plus 9 plus ... This one is example. That's example of a series because we use additional sign to link them. Go. Now let's take another one. We take 1 over 2 plus 1 on 4 plus 1 on 8 plus ... This one is also example of what? Series, because we use additional sign to link them. Go. So that's examples of series. Now we know the examples of sequence, we know examples of series. Go. Now, a sequence or a series can be either finite or infinite, depending upon whether it terminates or ends at a particular point. A sequence of series can be either finite or infinite, depending upon whether it terminates or ends at a point. Go. Now, if the sequence ends at a point, we call that one finite sequence or series. If it does not end, you just keep on going, we call that one infinite sequence or infinite what? Series. Go. Now let's take examples of finite sequence and series. Examples. So we start with the finite one. Let's start with the finite one first. Finite. I. Now 2 plus 4 plus 6 plus ... plus 100. That's the example of finite series. Finite series. Let's take sequence. RI. 3. Let's take 3, 5, 7, 9, 11, 13, 15, 17, 19. Go. So that's the examples of finite sequence because it ends at a point. Go. Now let's move on to infinite. Examples of infinite sequence and series. So we start with the first one. Let's start with the series. Now I'm going to take 4 plus 7 plus 10 plus ... This one is infinite series. Infinite series. Then let's move on to sequence. Let's take 2, 6, 18, ... So this one is also examples of infinite sequence. Infinite sequence. Go. So now what you have learned now up to this time is we now know how to define a sequence and series. We know that a term in the sequence is called a number in the sequence is called what? Term. When the terms are linked together algebraically, we have what we call what? Series. Now we know a series can be either finite or infinite. We know that for finite it ends at a point. Infinite is what? It does not end. It just keep on going. Go. Now we know examples of finite sequence series and finite sequence. The infinite series, infinite what? Sequence. Go. So the next step is to consider the types of sequence. Now we have about 4 types of sequence and series, but we are going to concentrate on the main 2 types. That's the linear sequence or arithmetic progression, or exponential sequence or geometric progression. So that's why we're going to consider the types of sequence. Okay, so types of sequence and series. Types of sequence and series. We start with the first one. We call that a linear sequence or series, or arithmetic progression. In short, AP. Good. Now, let me explain what talk about linear sequence. Now, when talk about linear sequence or series, any sequence or series where we obtain the next term by adding, you obtain the next term from the previous one by adding a certain number, we call that one linear sequence. Let me take it again. A linear sequence is a sequence where we obtain the next term by adding a certain number, and we call that one linear sequence. Let's take examples of linear sequence or arithmetic progression. Examples. Now, first one, when we take 3, 5, 7, 9, ... Now, this type of sequence, we obtain the next term by adding. And here the adding number is 2 plus 2 plus 2 plus 2. So that's the example of a linear sequence. Go. Now let's take another one. Now, this type of sequence, you obtain the next term by adding plus 4 plus 4 plus 4. And that one is called what? Linear sequence. Go. But a sequence where we obtain the next one by multiplying by a constant number, that one is called exponential or geometric. We'll get to that one later. So now we are going to concentrate on sequence and series. When we finish that one, then move on to the geometric or exponential sequence. Go. So here, these are the examples of a linear sequence. You obtain the next term by adding a certain number, and that adding number is called common difference. The adding number is called common difference. The adding number is called common difference. Go. So when we take this sequence, these examples, here the first one, the adding number is 2. The second one, the adding number is 4. So here the common difference, when we talk about common, that's the difference between two successive terms. When you subtract this, the first one from this one, or this from this, or this from this, it will give you the common difference. Go. So for the first one, the common difference is what? 2. But the second one, the common difference is what? 4. So the adding number is called what? Common difference. Go. So they can give you a question, find the common difference of this sequence. So when you say find the common difference of a particular sequence, you subtract the first term from the second term to give you the common difference. For example, when you say find the common difference